All right, so we need to have the two masses for this. The lowercase letter m in this case, the lowercase letter m is 25.5 grams. And the capital letter M, in this case, is, let me see if I can find my paper. Is that, there it is 45.0 grams. Both of these, by the way, are plus or minus 0.5 grams.
Is the lowercase m 25.5 because it's kind of cut off?
Yeah, I see it. There we go. It's a little cut off there. All right. All right, so now the fun part of the laboratory. The fun part. All right, let me prepare some stuff. Normally, when we do this laboratory, I have you actually work in groups of 4, because it really does, if you do it the best you can, take groups of 4 to do this. I'm all alone in my office. I'm going to get you guys to help me out as much as possible. Yeah, this is, let's see what this is. Okay, I need to point it up a little bit. Okay, how's this? All right, this is good. It's a little slanted, but it's good. That really is slanted. Okay, let me. My biggest problem with this kind of setup is I cannot see what's going on. All right, hang on. All right, so I need somebody in voice. So whoever's on voice before, you could do it, that'd be great. So somebody was talking to me before, I need somebody on voice. Somebody, anybody? Somebody talk to me?
Hi.
Hello. All right, so you're gonna be our caller. Let me point this up a little bit more. Okay, that's good. All right, so what I'm going to be doing is I'm actually going to be spinning this around. Going to be spinning this around like this, okay? Now the thing is I need to get this stabilized, okay? I need to get this thing stabilized. Once I get it stabilized, I will tell you that it's stable. After that point, you tell everybody when to start. You count 15 of these revolutions, and then you tell everybody when to stop. Okay?
Got it.
Got it? And then what I will do is I'm going to take this and I'm going to go over to my ruler, which is laying down over on the counter over here. And I'm going to measure the length of the radius. I measure it from the tip of the gold out to the middle of this, out to the middle of the cork. I have to kind of estimate where the middle of the cork is. But we realized when we were trying to have you do it more precisely, if anybody saw the old write-up for this, or the write-up that's in your manual now, where you actually tried to measure the cork and actually factor in half of the height of the cork and say, well, that's where the middle of it is. But we realized that the errors in this are much, much bigger than that is ever going to account for. So we're just going to say, hey. All right, so hopefully I'll get this one to work. If not, I'll switch masses and stuff. All right, here we go. All right, so let's see. All right, here we go. Yes. All right, we're ready.
Start. 1, 2, 3, 4, 5, 6.
Lost it. Sorry. All right, I gotta change it. I'm sorry. I gotta change. I'm gonna add another brass thing, weight to this bottom here. So instead of 45, it's gonna be 90, okay? So, but I realize I need to do that because it's not, I can't stabilize it as is. All right, sorry. That's just too hard to stabilize. So we're gonna, instead of 45.0, it'll be 90.0.
90.
And hopefully I'll be able to stabilize it a little bit better. Now it's going to go a lot quicker too. You may be only able to count in your head. That's all I can say. All right. It's going to be whipping around a little bit faster. There we go. At least it's not as bad as what happened in the first lab when I couldn't even get the string to go through the thing because I was trying the wrong string. So this time at least I'm trying the right string. All right. Yeah, what was going on there is as I was spinning it, some of you might have noticed that it was actually getting longer. That's a no-no. So I need to stabilize this so it doesn't get longer or shorter. That's what I need to do. So in other words, I have to add just enough energy in here to overcome the friction, but no more. So I do this. Okay. Okay, go a little shorter here. Let's go short. You got it.
Start.
You count 15 of them, right? Oh, I lost it again. All right, so you say start, count 15, and tell everybody to stop, because you got to tell everybody to stop too, okay?
Oh, I counted till 38.
Wow.
Sorry. I counted
Okay.
up to 38.
I was like, I was like, you guys start. So you say start, you count 15, you say stop, okay?
Okay, got it. That's really
All right,
good.
let's try it. Let's try it one more time, everybody. Ready? All right, we're stable.
Start. $15, stop.
No, don't lose it, don't lose it. All right, so type times in chat for that 15. And let me write the table up here. And so we have R and the T15. So what kind of T15s do we get? 7.80, 6.68, I'll just pick 6.68. These are in seconds. And the R is 15.0 centimeters. Okay, so now I'm going to try one that's a little longer. Not that long. Okay.
Start. 13, 14, 15, stop.
All right, times in chat. So we got 8:15. Okay. And we're clink on. All right. Go to the next one. No, don't twirl up on me. Okay. All right. We're good. Okay. Are you still there? Oh, we lost our caller.
Sorry, I was muted. I thought I was on.
All right, let's try that again. We'll get this. We'll get this. Okay, let's do this right here. This is good. Okay, hang on. All right, we're good.
All right, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Stop.
That one was about 49 centimeters. And your time?
Did that say 10.14?
Yes, I just grabbed one out of chat. You're actually taking your own time or your partner's, okay? Or if you didn't do it, then yeah, like, you can use the chat. Just one of them out of chat. I'm just grabbing them out of chat. Definitely not timing to myself, and I'm definitely not knowing if any of these are correct or not. Let's try this one. Okay, it's about as good as we're gonna get.
Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Stop.
Okay. Time was in chat. I'll take the, I don't know, 13. Oops, 1328. And this was 89.0. All right, one more. Come on, stay together. We got one more here. All right. Hope we can do this. All right. Oh, nope, too big. About as stable as it is ever going to get. Oh, no, no, no. Ha! All right, I have to do a shorter one. I'm sorry. I can't do that one. Now let's try to go about here. Let's see if this works. All right, let me see if I can aim for one. See, I didn't have anything between 49 and 89, so maybe if I do this one. I'm going to try this one right here. Try to get one right there. That sounds good. That sounds pretty good. That sounds good right here. Okay. It's difficult. All righty. We're stable.
Start. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Stop.
Ow! All right, so that one was about 65.0. And 11.03. Just let me block this stuff off. All right. All right, everybody. Let's do some analysis here. All right, so I'm going to use Excel to do this, and I'm going to use the numbers that are back on the board. You use your numbers. Please use your numbers or your lab partner's numbers or whatever numbers you picked out of the list on the chat. In other words, I'm hoping that when I get your papers, they will have slightly different numbers than mine, which is great, so I'm going to now open up Excel. You don't have to use Excel at all for this. The only thing you will actually need, you can actually just do this stuff on your data sheet. The only thing you will actually need is average and standard deviation. And so when you do that, you can use whatever program that you would like. You do not have to use Excel for that, okay? If we were drawing a graph and we were going to get fancy, then yes, I would have asked you to use Excel, but we're not in this case. All right, so let me just record my data over here. So let me actually share you the thing. Notice I put it in old man because I'm an old man. So here we have R, and here we have the lowercase letter t. I'm going to make this center these just because that's what I do. All right, so I'm actually going to put these in order of the lengths. So when you transfer these to well, I'll talk about that in a minute. So I'm just going to do this. I actually do want that last decimal point to be shown. So this. So 15.0, 25.5. Then we had 49.0, and then we had 65.0, and then 89.0. And our lowercase letter t's are 6.68, or our classroom ones, 8.15, 10.14, 11.03, and 13.28. So unless those are actually the numbers that you or your lab partner made, I want every group to make sure that at least one of those numbers is chosen differently from the ones that I chose, okay? I would rather it be your numbers that you measured.
This is solving for big T, right?
Okay, so the first thing we're going to do is we're going to transfer these numbers from the lower left table to the one in the upper right, okay? So our capital letter R, we have a choice here that we can use either centimeters or meters for this. Centimeters or meters, it doesn't matter. So which one do you guys want to use for this, centimeters or meters?
Meters.
You want to use meters? All right.
Centimeters.
It's too late because he said it first and he said meters. All right, so you guys can actually use centimeters in your own analysis if you want. It's not going to follow mine, which is great. So what do I need to do with each one of these numbers to make it into meters? These are in centimeters. What do I need to do with each one? Divide by what? Oh, let me pull up the chat.
100.
Yeah, we're going to divide by 100. Where's the chat? Where's my chat? Give me my chat. Where's my chat? No, I said chat. Give me the, where did it go? I don't know why I can't see the chat. Is anybody typing in the chat? Somebody type in the chat. I gotta figure out what happened to it. Okay, there's the chat. All right, well, let's see what I can do with this. Pop out. There we go. Now I got the pop out chat. All right.
Professor, can I ask a question?
Yes, you may.
We're doing now the time for 10 revolutions, right?
Time for 15. The time for 15 are the times that we recorded, okay?
Oh, for 15. Okay, so we
Yeah, that's why I said to change that.
Oh, okay, so what are we doing now? We're just giving the standard deviation for it?
Hold on. don't get ahead. I'm just transferring this stuff to the upper right. So
Okay.
as you can see what I'm doing here, see? Don't get ahead. Don't get there. All right, now we need capital T. For capital letter T, what do we need to do with lowercase letter t's? I need to
Divided by the time.
No, divide by what?
I'm sorry, 15. That's what I mean.
15. So I need to, so the units here, by the way, for the little times, are in seconds, as will the units of the capital T's are. Okay? Technically, we can keep as many significant digits as there are over here. Because we're dividing by 15. 15 is an exact number. I did not have my timer estimate. Was it really 15 and a half revolutions or anything like that? No, 15. 15. So we're just going to take these numbers, divide by 15, keep 2 decimal places, you should be good. Or maybe 3. Keep 3 decimal places. All right, so take this, divide by 15. So I'm going to do mine. So I get this. Okay. In fact, I'll just do this one. I'm going to use an Excel shortcut. There we go. Now, notice what should happen with your data. Notice as the length goes up, as the radius goes up, so does the time. So you always want to kind of look for patterns with that. So as the radius of this thing goes up, so does the time. All right, so now let's go to calculate our value of G. So the first thing I'm going to need is I'm going to need the lowercase and uppercase letter n's. Okay, so lowercase letter n, uppercase letter n, and our kappa. Okay, so lowercase letter n was 25.5 grams. So these are grams. I'll actually write grams here. And the capital letter N was 90.0 grams. Okay. Whoa. So now our kappa. Let me remind you how to calculate kappa. Kappa is going to be our constant that's in every one of our things. And we only want to calculate it once. So kappa is equal to 4 times pi squared little m divided by capital letter M. So somebody calculate that for our lab setup. Since we use the same 2 masses for all 5 radius, that kappa should work.
Is it like 11.2?
Chat, is that what we got? Is that what you guys got? Do I get a confirmation on 11.2? 11.19? Okay, good. 11.2 sounds great to me. Now, just to ask you a question, how many significant digits should we keep in this number? How many should we keep? So should it be 11.2 or 11.19? Which one should it be?
Can you share your screen, please?
Sorry. You saw me looking at the screen. You're like, why are you sharing the screen? So in other words, which should this be, 11.2 or 11.19? Which one should we do?
3 sig fig.
It should be 3 sig figs. Because I calculated a number, and the only ones I have here are 3. The 4 and the pi's are infinite, so the lowest number is 3, so we keep 3. There we go. The only time we add 1 is if we're taking an average. That's the only time we can add a significant digit. All right, so now over here, I'm going to make a column of experimental values of G. So I'm going to cut, I know. So this is my G experimental. These are my experimental values of G. And these are going to be in meters per second squared. I have to use that. Okay, so that's my units. Okay? So now to get that, what I do is, let me stop, and I'm going to share the way to calculate it. So now my G is going to be equal to my kappa times R divided by T squared. Kappa times R divided by T squared. All right, so let's calculate kappa for our first one. Let's calculate kappa for our first one. Okay, so, I'm sorry, let's calculate G for our first one. We already calculated it. So it's equal to kappa times R divided by, parentheses, T times T. That's Excel. All right, so somebody tell me what you got for your first value of G.
8.48.
What'd you get?
8.48.
8.48? Okay, well, let's see. Let's see what I got. And other people might get something different. Remember, your times are going to be slightly different. Some of your times are going to be different. I got 8.47. All right, so we're going to reduce this to 3 significant digits because that's all we have here. Okay, that's all we have. So 3 is 8. Okay, ready for the next one? So let's just calculate the rest of these too. So I'm going to calculate all these up. Equals kappa times R over, I have to use it parentheses on Excel, E squared. Second one. All right, somebody type in chat what you got for the second one.
9.69.
Ooh, better, better. Yes. Ooh, we like that, right? Because we know we're kind of aiming for 9.8. So there we go. 9.67 is good. 8.47, not bad. Okay. Some of the results on this would give you like 5 or 15 or something like that. I mean, the results of this vary wildly. So, you know, getting 8s, that's pretty good. Of course, I did have to change the setup to get it. I think if we'd gone with that first setup, we would have had really bad numbers because I couldn't control that thing. And that's the problem when you use different weights, is you might not be able to control it as well, or it will go too fast and you won't be able to see it. All right, so let's do this one. Throw in this one. R. Oh, yeah, a bit too big error. All right, we'll keep 2 decimals. Uh-oh. Yeah. And let's see our last one here. All right, so let me just ask you guys, just take a look at this data, and if I ask you this question, does this setup work better for smaller radii or larger radii? What would you say? Just type in chat. It's a 50-50 shot. Does it work better for smaller or larger?
Smaller.
I see a smaller. I hear a smaller. Anybody else smell for smaller? Anybody else not say smaller?
Is in between an option?
No, it's actually, you're right, in the first place, smaller. Because it's kind of obvious. These numbers are a lot closer to our expected value than these. Okay? And so that could be seen by the fact that the larger those things were, the harder they were for me to control and get to actually spin consistently. So yeah, that's why some setups just work better than others, and this one works okay for the smaller numbers, but for the bigger numbers, it just starts going wee, you know. Okay. All right, so So now what we want to do is we want to take an average and a standard deviation. Okay, so that's actually, this is actually the, let me show you the table that we're working on here. New share, give me this. All right, so we filled in this table here, and now we filled in for the gravity, so you have 5 of those. Now we're going to take the average and standard deviation. Average and standard deviation. And so I'm going to do that on Excel. You guys can do that on whatever program it is, or if you have Excel, or if you have your calculator when you do it. By the way, those of you with a graphing calculator, I'm going to type this in the chat. It's, you want to look for SX when if you're using your graphing calculator. Okay? So here we want the average. So we just say that this is equal to, on Excel, it's average of the numbers. Don't you, what, wait, stop it. What did you do? Equals average. Thank you. Now the numbers. Now in parentheses. Now this. Thank you. And then we want the standard deviation. So in Excel, this is the dev S, meaning sample. And now let's reduce this. Okay, so for number 4, instead of just calculating the relative uncertainty, I would like you to calculate the percent uncertainty. So we want the percent uncertainty.
Oh, number 4 was on a second page. Oh, you only just printed 1 page.
Oh, okay, that's fine. Just put it down at the bottom of the front page. Okay, and then we're going to do percent error. Okay, for number 5. So I got a number 4, number 5, and I'll put those on the board for you. Okay, so for number 4,
I know I shared it with you guys.
so for number 4, we want percent uncertainty. And the percent uncertainty is equal to sigma g over the average multiplied by 100. For the percent error, it's equal to the experimental g minus the accepted g, or the theoretical g, divided by theory, multiplied by 100%. The theoretical g for Northridge, I'm going to go ahead and round it off. It's 9.80 meters per second squared. Now, how many of you in all of your fanciness thought it was 9.81? How many of you thought it was 9.81? It did it. It did in the chat if you thought it was 9.81.
Wait, it's G experimental minus G theoretical over G theoretical?
Yes, it's always experiment minus theory divided by theory. And you take the absolute value. The 9.81 is actually at sea level. And since we're up a bit higher than that, it's actually just 9.80. Okay, so I'm going to calculate mine on a little sample here. So you write number 4 and number 5 on the front page here. And I'm going to go ahead and share my calculation with you guys. My calculation, you share yours, which will be slightly different. Some of you might have timed this thing better, right? You might have timed it better. I was just picking random numbers out of chat, right? All right, so the percent uncertainty, 100, I'm going to include the 100 first here. Standard deviation, divided by. And I get 18.47%, 74%. With percent uncertainties, in general, you can really round those off to just the whole number here. Okay? You don't have to, because we generally use a percent error and a percent uncertainty to get an idea of how either accurate or precise an experiment is. Okay? Now percent error. So we take equals, I'm going to do the 100 thing here, multiplied by the absolute value of this minus 9.8 divided by 9.8. So what I got here is 15%. Yeah, 15%.
Do you think you could show your board one more time so I can see the formula?
Oh, yeah, no problem. I'm actually going to go back there. I just wanted to see kind of what I got. So some people type their uncertainties and stuff in chat. And let's go ahead and put 1 decimal place on it just for looks. So 18.7 and what was this, 14.9? Well, 15.9. All right. So I'm going to go back to the board here. There you are. We're actually pretty close to being done for the semester. I'm going to miss you guys. And I didn't even get to see you after spring break. That was it. Isn't that amazing? That's weird, huh? Like the last time you saw me, everything was kind of normal, and then everything just went happen. 8.78. Nice.
Professor, do you want the balls back?
Do I want the what?
Because you gave us like those ping pong balls.
You guys have the 3 balls.
Yeah.
I know.
And also the tape measures. We have tape measures as well.
Yeah, just if you I don't. Well, the thing is, just keep them for now because I would even need to know. I mean, maybe we'll just cut it as a COVID loss, right? What are we going to do, right? You know what I mean? There's nothing we can do. So, and I don't understand how I can't demand them all back at once because we can't have you all come together. See what I mean? So yeah, just keep them and say this is our COVID compensation right here. This little ball and 3 balls, and I'll ask my boss about it, I guess. But in terms of me, I'm just like, what are you gonna do, right? What are you gonna do? Because did I tell you guys that over the summer we're online still here at CSUN? Over the summer, we're online still. I'm a little bit more prepared for it than when I was, when they first made us go online, right? And we did kind of look out in here because we were kind of half online anyway. But all this, I had to move this out of the lab room down to my office because the computer in the lab room won't do the video stuff. Okay, did everybody get this? So I can go on to the questions? The 2 questions I'm going to actually have you answer?
Yes.
All right, so on the back or on the side or somewhere on the paper, you and your partner are going to get together. Oh, that's right. I got to change this. Don't submit it yet. I'm so sorry. Oh no, I hope I did. Oh no, I probably didn't. Let me see. Maybe I did. All right, since I'm panicking, I'm going to share my screen and let you know what I'm doing. I have to make sure that I put this up as group assignment. I think I did. I hope I did. Let's see. Yes. Okay. All right, we're good. Yes, the journals, it's okay. You can retype your stuff in Word if you want. I would rather have pictures of what you wrote before. Can you do that? Can you take pictures of the stuff you did before? I'm mainly looking for the stuff you did before we went away. But you can just take pictures and put them in like a PDF or something.
Professor, I have a question about the journal.
Yes.
What if my journal is like 50 pages long? Like, do you want me to submit 50 pictures?
Wow.
Because like I have all the way from lab 1 to to this lab, and like each one each lab has like 4 pages to it. So
could you put them all in one file?
Yeah. So you want me to submit every single picture, or do you?
I would like that if you could. Yes.
Okay.
If that's not too much trouble. Yes. If the file's not too big. Yes.
All right.
If you put that much work into it, I want to give you credit.
All right.
You hear what I'm saying?
Yeah. Wait, how many points is the journal worth?
Well, it's supposedly worth 20, but I'm going to look at it for more of a cursory thing. But I want to give credit where credit is due because the people work really hard on that. maybe I'll use it to make up for points you might have missed on the lab or something. See what I mean?
Got it.
Okay.
I have a question about lab 11. I know this is kind of like off topic, but if we submit a lab 11 today, is that fine?
That's fine.
Okay.
I mean, I would rather people be able to turn them in, but I can't even do that now. I mean, because they shut everything, Yeah, everybody, I mean, it is what it is. So I guess the people who really didn't do their notebooks that well kind of luck out because, they would have gotten kind of punished for not doing a notebook. Now it's kind of like, no, you actually just get rewarded for doing it.
Yeah.
For the labs you did at home, if you have Word files that you wrote up for the lab journals, the second half, you can submit those Word journals. Yes, for the second half. The first half, you were keeping your regular notebook, and I would want pictures of those that were written. All right, so let me go back to share. Let me go back to share the board. Actually, let me stop the share. Let's take care of this lab first, and then I can answer the other questions. All right, because I know you got questions about that. All right, so the two questions I want you and your lab partner to talk about is, first of all, evaluate this lab on the basis of precision and accuracy. So you want to go back and check what that is. Basically, there are 4 things that you can say about this laboratory. You could say it was precise and accurate. You could say it was precise but not accurate. You can say it was accurate but not precise, or you can say it was neither. Or you can kind of say, you can quote numbers that will pertain to these. Or you could say it was sort of accurate, or semi-accurate, or just as accurate as it was precise, or something like that. The second question, suggest changes to improve it. Maybe 1 to 2 sentences here, 1 to 2 sentences here. I don't want you to write a book on how to change it.
Can I ask a question, Professor?
Yes, go ahead.
This is in addition to the question that we have on
No. This is instead of the questions that are back there.
Oh, instead of the, okay.
Yes, because the questions that are back there told you to compare other setups with different kappas. The thing is, everybody has the same kappa because we all use the same setup, so there's no way to really do that. So, okay?
I appreciate that, thank you.
So it's these questions, not the other questions.
Okay, thanks.
So there's those 2 questions. All right, now I'm going to stop the recording here.